Hey guys, so I'm gonna pick back up here on page 32 of our chapter 11 handouts. We had just finished looking at parabolas and identifying the major characteristics. Now we want to talk about how to actually plot them intelligently. In other words, I know you could just like pick x's and calculate y's and plot them that way, but there's a better way to do it, and that's what we're going to cover. Now, what we're not going to cover is this first method, okay? This completing the square to get the vertex form of a quadratic equation. I was looking back at our department syllabus, and that method comes from section 11.5, which specifically is not in the syllabus. So therefore, we are not going to do it. So that means this whole page, and then the top here. So the only comment I will make, it's not on the syllabus, so therefore it shouldn't be on the final. But in case something slips through, like for example, you see this right here, f of x equals quantity x plus 1 squared minus 2. So that's just a parabola written in vertex form, which again, we're not covering. You can just multiply that out. You know, that just means x plus 1 times x plus 1, and then minus 2. Okay, and then if you FOIL that out, it's x squared plus x plus another x, so plus 2x plus 1, and then minus 2. Okay, and so then if you combine those constants at the end, 1 minus 2 would become minus 1. So that's just equivalent to x squared plus 2x minus 1, which is the form that we want it in to do this second method. Okay, so if you do happen to see a quadratic like that, that's all you have to do. Just multiply it out to get it into standard form. All right, I'm going to erase that. And let me just scooch down a little. So we're going to start here on the second method. And again, what we're doing here is we want to plot a quadratic. We're going to just use a formula to find the x-coordinate of the vertex. Okay. The formula for the x-coordinate of the vertex is x equals negative b over 2a. That's it. Okay, so again, this is when you have your quadratic in standard form. So in other words, you have ax squared plus bx plus c equals 0. Okay, so the b and the a right here are coming from right here. All right. And it's kind of like, oh, no, not another formula to remember. But if you recall your quadratic formula, let me just write it off to the side here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, you're ultimately going to have to memorize this. So the nice thing is that this formula is right here. There's your x equals negative b over 2a. So it's not like a separate thing you have to memorize. It's built into the quadratic formula. Okay? All right, so for example, f of x equals negative 1/2 x squared minus 2x minus 2. We want to find the vertex, so x equals negative b over 2a. All right, so let's see, b is negative 2. So in other words, the negative of negative 2 over 2 times a is negative 1/2. All right, so the negative of negative 2 is just 2. And then in the denominator, there's a 2 over 2, and I'm left with the negative 1. So that equals negative 2. Okay, so that's the x-coordinate of the vertex. Well, that's only half the point. We want to be able to plot the whole point, so how do we find the y-coordinate of the vertex? Okay, well that's easy, because once you know x, all you have to do is plug it back into the function. Okay, it's f of x. So in other words, we just calculated that the x-coordinate is negative 2. So all we need to know is what is f of negative 2. Okay, so just plug it in. Well, it's negative 1/2 times negative 2, quantity squared, minus 2 times negative 2, minus 2. All right, let me come back here and simplify. So negative 1/2. Negative 2 times negative 2 is positive 4, so this is times 4. Minus 2 times negative 2 is negative 4. And then minus 2. All right, so negative 1/2 times 4, that's going to be negative 2. Minus a minus turns into a plus. All right, so I've got negative 2 minus another 2 is minus 4 plus 4. So that winds up being 0. Okay. So therefore, the vertex of the parabola that you get when you plot this quadratic function is at the point negative 2, 0. Okay. All right, I'm going to erase all this so I can finish this at the very bottom here, how to generically write the formula for the vertex. Okay. You can generically write it as negative b over 2a. So that's the x-coordinate, and then comma f of negative b over 2a. Like that. So again, that's just describing x, comma, y. All right. Or it turns out that there is actually also a formula for the y-coordinate of the vertex. Okay, let me just come up here. All right, the y-coordinate is equal to 4ac minus b squared divided by 4a. All right. So I personally have never bothered to memorize that formula because there's no need, because it's so easy to remember the formula for x. And then all you have to do is take that number, again, plug it back into the function, which in my opinion is much easier than trying to memorize this. Okay? All right, I'm going to go on to the next page. Okay, so this is just a summary of the method. Let's take a look at this. First, okay, so again, you've got your parabola, you've got your quadratic in this form, ax squared plus bx plus c. First step is just look at the equation to tell you if the parabola is going to open upwards or downwards. Okay, so remember, if a is positive, then it's going to open up. If a is negative, then it's going to open down. Find the vertex of the parabola. So again, we're not going to cover this first method. What we just covered was the second method, the formula method. Just calculate the x-coordinate. X equals negative b over 2a. And then the entire vertex is, I don't have room, I'm going to do it over here. Again, it's negative b over 2a. And then f of negative b over 2a. Okay, it's just the y value that you get when you plug x in. So, okay, we know the vertex now, so you can go ahead and plot that. Identify the line of symmetry. Remember, that's the vertical line that goes straight up and down through the vertex. We were looking at those the other night. The equation of that line is x equals negative b over 2a. Just that's the value of the x-coordinate of the vertex. Okay? So that gives you the line of symmetry. X equals a constant. Identify the maximum or minimum value of the parabola. And that is going to be the y-coordinate of the vertex. And again, it's going to be a minimum if the parabola opens up. It's going to be a maximum if the parabola opens down. In either case, it's going to equal the y-coordinate of the vertex. All right, I'm going to erase that and move on, or move down. Calculate some additional points to plot. Basically going maybe 2 to 3 values of x to one side of the vertex, calculate y, and then using the symmetry of the parabola to obtain points on the other side of the vertex. It's going to be perfectly symmetric, so you don't need to calculate more points, just use the symmetry. I'll show you what I mean when I do an example. So then you have, maybe this many points total plus the vertex, and you got enough to have a good idea. Just go ahead and connect the points with the smooth curve. Also, if you want, you can find, if you haven't already, you can find the x and y intercepts to plot. Right, so to find the y-intercept, you set x equals 0 and calculate y, which is very easy because this drops out, this drops out. Y-intercept is just the point 0, c. So you would typically find that one just because it's easy to calculate. To find the x-intercepts, set y equal to 0 and calculate x. This is what we've been doing all along. Ax squared plus bx plus c equals 0. Solve using any method. You may find there are 2 x-intercepts. There may be 1. There may be none. Okay. All right, so let me go on to the next page and I'll do an example. All right, am I going to have enough room? I'm going to make this a little smaller. Okay, is that... Okay, so I'm on page 36 now. I'm going to do this example of how to plot this quadratic function. We've already got it in ax squared plus bx plus c form. So we can see a is 1, b is 2, c is -5. Okay, first thing we notice that a is greater than 0. So that just tells us that the parabola is going to open upwards. Okay, we want to find the vertex next. Okay, so x equals -b over 2a. All right, so that's going to be negative, and b is 2, over 2 times a is 1. So there's -2 over 2 is going to be -1. All right, so for y, then we're just going to take -1 and we're going to put it back into the function. We're going to find f of -1. I'm just going to come over to the side here so I have more room to do that. So f of -1 is going to equal, so it's x squared, so quantity -1 squared, plus 2 times -1 minus 5. All right, -1 times -1 is 1, and then it's going to be -2 minus 5. All right, so 1 minus 2 is -1, -1 minus another 5 is -6. All right, so the y-coordinate is -6, or in other words, the vertex is the point -1, comma, -6. And if you want, we can go ahead and add that to the graph, -1, -6, right down here. Go ahead and plot that point. The line of symmetry goes through the vertex. So in other words, the equation of that line is x equals -1. All right, and the parabola is going to be symmetric around that line. If you want, you can draw that line of symmetry in. Because it opens up, we know that the vertex is at the very bottom of the parabola. Therefore, we are going to have a minimum value. So I'm on number 4 here. The minimum value, and that minimum value is the value of y at the vertex, which is -6. Okay. All right, number 5, then we want to just calculate a few extra points. Okay, so let's just move to the right. Let's move to x equals 0, just because that's easy. When x equals 0, and when we plug that in to this function, 0 squared is 0, plus 2 times 0, that's 0, minus 5. Okay, so that one's really easy. 0 minus 5. All right, and we can go ahead and plot that. Now here's what I'm talking about with the symmetry. Okay, this is going to be perfectly symmetric around this line. So in other words, from the vertex here, we went over 1, up 1. Therefore, we can add in another point on the other side of the line if we just go to the left 1 and up 1. So this is also a point. The point -2, comma, -5. And we don't even need to calculate it. All right, let's calculate another one. Let's move to the right one more time to x equals 1. Okay. And again, we're just going to take that value. We're going to plug it into the function. I'll just write this one out. So f of 1 is equal to 1 squared plus 2 times 1 minus 5. So that's 1 plus 2 is 3. 3 minus 5 is -2. So that's the point 1 comma -2. 1 comma -2 is right here. Go ahead and add that. So you can see we're 2 units to the right of the line of symmetry. So in other words, we can just go ahead and add another point in 2 units to the left of the line of symmetry. Right there, the point -3 comma -2. And let's just do one more. Let's go to x equals 2. Okay. Plugging that into the function, we're going to have, see, 2 squared plus 2 times 2 minus 5. So this is 4 plus 4 is 8, and 8 minus 5 is 3. So that's the point 2 comma 3. So 1, 2, 1, 2, 3, we're right here. Notice now we are 1, 2, 3 units away from the line of symmetry. So if I just come straight here and then I go 1, 2, 3 units this way, I can make a point. Okay. So that's more than enough points. Now you would just want to draw a nice smooth line through that. I'm going to do my best, but I'm hoping for a decent outcome here. Okay, actually that's not too bad. All right, so generally that's what the plot of that is going to look like. From the graph then, we can list the domain. I know everybody knows this. For any quadratic function, the domain is all real numbers. In other words, -infinity to +infinity. For the range, it's always easier to look at the graph. So the lowest value that y can be is -6. And then it's just going to go all the way up to +infinity. So the range is going to be bracket -6, comma, infinity. Okay. And then up here, back up to the top, number 6, find the intercepts. So we already found the y-intercept, which was the point 0, comma, -5. See, that one's always easy to find because you're just putting in x equals 0. The x-intercepts, and just notice, we don't need the x-intercepts. You know, you can kind of see about where they are here and here. We don't need them to make the plot, but there may very well be a question on the test that just gives you a quadratic function like this and says find the x-intercepts. So again, to do that, you just set y equal to 0 and you solve. So in other words, take this function, x squared plus 2x minus 5 equals 0, and solve it. And in this case, it certainly doesn't look like it's factorable, so I would just use the quadratic formula. Okay, so x equals -b, so that's -2, plus or minus the square root of b squared. Okay, so 2 squared is 4, minus 4 times a is 1, times c is -5. All of that over 2 times a is 1. Okay. So let's see, -2 plus or minus the square root of, what do we have in here? We have 4 minus a minus 20, which is going to turn into 4 plus 20, or 24, all divided by 2. Okay, now think about 24. It is 4 times 6, and 4, of course, is 2 squared. 6 is 2 times 3, so it doesn't have a perfect square. So I can remove a factor of 2 from under the radical, and then I'm going to have a factor of 6 left underneath there. All right, so negative 2 plus or minus 2 times the square root of 6, all divided by 2. And then, okay, so everything is over 2, and I can take a factor of 2 out of both of these. So we need to do that to simplify it. So the 2 over the 2, okay, leaves me with a 1, and then this 2 over the 2 leaves me with a 1. So we end up with negative 1 plus or minus the square root of 6. Okay. And again, that's two solutions. Negative 1 plus the square root of 6, and negative 1 minus the square root of 6. And those are the x coordinates, so the full point would be that, comma 0, and that, comma 0. All right, so those are your two x-intercepts. All right, pause if you're not done. I'm going to erase and go on to the next page. Oops. All right, this one. Okay, f of x equals 2x squared minus 16x plus 29. And I want you to pause at this point and take a few minutes. Try to do this one by yourself. Exactly the same steps we just did in the example. So, seriously, pause it. Okay, now, really, pause it. All right, so let me run through this one real quick. Presumably you have already done it. 2x squared minus 16x plus 29. Again, a is greater than 0, so it's going to open up. Finding the vertex, x equals negative b over 2a. All right, so b is negative 16, so negative b is positive 16, and then over 2 times 2, so that's 16 divided by 4 is 4. For y, just plug it back into the function. So 2 times 4 squared, because again we're finding f of 4. We want to find the y coordinate when x equals 4. So 2 times 4 squared minus 16 times 4 plus 29. All right, so this is what? 4 squared is 16. 2 times that is 32. 16 times 4 is 64, so 32 minus 64 plus 29. And if you add all that up, it should come out to negative 3. Okay, so y equals negative 3. That means the vertex is the point, 4 comma negative 3. All right, so 4, negative 3, there's our vertex. And our line of symmetry is going to go up and down through that vertex. So the equation of that is going to be x equals 4. We can go ahead and Draw that in if you want. Whoops, hand slipped. All right, and again, because it's going to open up, that is going to be a minimum value there. And the minimum value is the y value at the vertex, which is -3. Okay. And now let's calculate some other points. We're at 4, so why don't we move to the right one to x equals 5. All right. So now I'm not going to write it all out this time, but what you want to do is substitute in x equals 5 to the function. So you're going to do 2 times 5 squared minus 16 times 5 plus 29. And when you do all that, you should find that y equals -1. Only potentially tricky thing is, remember you have to do that 5 squared first, then multiply by 2 for the correct order of operations. So we have the point 5, -1. And then by symmetry, you see how that's 1 unit away from the line of symmetry? Then we can automatically draw another point here at 3, -2. All right, let's go to 6. X equals 6. Okay. If you plug that in, 2 times 6 squared minus 16 times 6 plus 29, you should get y equals 5. So 6, 5. So that one's way up here. So now we're 2 units away from the line of symmetry. So then just go 2 units this way, right there. So in other words, this is kind of a pointier, skinnier parabola than the last one we did. So it's kind of like that. From that, we can list the domain, as always, all real numbers, -infinity to infinity. The range, okay, the lowest value here for y is -3. So it's going to be everything from -3 on up. So bracket -3, infinity. Okay. Finding the intercepts. So for the y-intercept, again, just set x equal to 0 in the function. So 2 times 0 minus 16 times 0 plus 29 equals 29. So the y-intercept is actually the point 0, 29, which we can't even graph it because it's way up here somewhere off the top of the chart. The x-intercepts, set y equal to 0. So then we have 2x squared minus 16x plus 29 equals 0. We can't divide through by anything to simplify that first. So just go ahead and use the quadratic formula. I'm not going to do all the steps. You should get to a point where you have x equals 16 plus or minus the square root of 24 divided by 4. Okay. And again, we just saw in the previous problem that 24 is 4 times 6, so you can take out a factor of 2. So that becomes 16 plus or minus 2 times the square root of 6 over 4. Okay. And let's see, we could go a couple different ways with this. If we want to leave it all over the same thing, we can only take out a factor of 2. Or we could just separate this and write it like 16 over 4 plus or, what? Hold on. Plus or minus 2 times the square root of 6 over 4. Okay. So now you can see that this becomes 4 plus or minus, and then here I can take out a factor of 2. So that becomes plus or minus square root of 6 over 2. All right. So if we had wanted to simplify up here and just keep everything over the same denominator, I could only take out a factor of 2. So in other words, this would become 2. 2 over 4 becomes 1 over 2. And then the 16 over the 4 becomes 8 over 2. So that would have ended up as 8 plus or minus the square root of 6 over 2. Okay. So these two things are equivalent. I guess you just kind of never know exactly what form the answer is going to be in. All right, pause that if you want. I'm going to erase and go on to the next page. All right, let's move on to the next section, which is section 11.8, polynomial and rational inequalities. And this is something you probably have not seen in a previous class at all, unless you've taken this class before. So the objectives are to solve quadratic inequalities, solve cubic inequalities, and then to solve rational inequalities. So let's start by just looking at the quadratic inequalities. All right, there we go. Okay, so here is a quadratic function, f of x equals x squared minus 2x minus 8. If I set that function equal to 0 right here, then I get the quadratic equation, x squared minus 2x minus 8 equals 0. Or in other words, what x values, if I put them in here, give a function value that is equal to 0. Okay, so as we already know, the solutions to this quadratic equation give the x-intercepts, because that is where y is equal to 0 on the x-axis. So we can see that this is one of them here, and this is one of them right here. Okay, so the solutions to this are x equals, okay, so this is -2, and this is 4. Okay, and we also could have solved this, you know, say we didn't have the graph just sitting right here. We could have also solved it analytically by just factoring this. That factor is pretty easy. It's just x minus 4 times x plus 2 equals 0. And that would also give us the solutions, x equals 4 or -2. Okay. So the whole point here is that y equals 0 when x equals either 4 or -2. So that's just a straight up quadratic equation. Where is y equal to 0? So now we are asking a different question. We're asking, where is this greater than 0? Okay? So in other words, that's kind of the same thing as asking for what x values is f of x greater than 0? Or where is y greater than 0? Okay? So we want to look on this graph and say, where on this graph is the value of y greater than 0? Well, here's the origin where both x and y equal 0. Anything north of that, y is greater than 0. So that would be like this part of the graph or this part of the graph. Okay, that's where y is greater than 0, up here. But the thing is, when we write the answer, we need to write it in terms of x. All right, so we want to say, well, that's where y is equal to 0, but which x values will give me these y values? Well, it looks to me like any x value to the right of this will give me a y value that's greater than 0. Or any x value to the left of this will give me a y value that is greater than 0. See, any x in here, okay, if I go x, y, it's down here, and y is negative. It's less than 0. Okay? So, in other words, the solution to this question, where is the function greater than 0, is going to be negative infinity up to this point here, which is x equals -2, not including it because at -2 it equals 0, and then union with starting here and everything to the right. Okay, so 4, comma, infinity. All right, so again, we're listing as our solution to this inequality all of the x values that make this true. These are all of the x values that result in y being greater than 0. All right, I'm going to erase all this stuff so I can redraw on the graph, okay? So, what if we ask this question? X squared minus 2x minus 8 is less than or equal to 0. Okay? So now we're asking for what x values is f of x, or y, less than or equal to 0. Well, again, we already know at this point and this point y equals 0. And then we can also tell just from looking at the graph that for all of these points here, that y is less than 0. Okay? But we want to, again, describe our solution in terms of which x values. So for any x from -2 up to 4, including those endpoints, if I put any of those x values in, then my resulting y value is going to be less than or equal to 0. So the solution is, and this time it's a bracket, -2, 4. Okay. All right, so it's pretty easy to solve these if you have a plot. All right, but what if we don't have a plot and we want to be able to solve it analytically? Okay, well, there's a method for that. Let me go on to the next page. Okay. All right, so this method makes use of the fact that a polynomial will have a constant sign, either positive or negative, within each interval between its real zeros. Okay, and just a reminder that the real zeros means it's x-intercepts. Okay, and when we are talking about the sign of the polynomial, we are talking about the output value or the y value. So in other words, between the zeros, the intercepts, all of the y's will either be positive or all of them will be negative within those intervals. Okay. So let's look at this same quadratic function again that we were looking at on the previous page. And we already noticed that there are zeros at x equals 4 and x equals -2. Okay. So notice that those two zeros divide the number line, the x-axis, into 3 different intervals. Okay, so essentially the intervals are from -infinity up to this 0 to this 0, and this 0 up to +infinity. Okay. Notice how in each interval the function value y is either positive or negative. Okay, so in this interval from -infinity all the way up here, where are the y values? Well, they're all up here. Okay, all the y's are positive. In this interval between the two zeros, so through here, where are my y values? Well, they're all down here. They're all negative. And in this third interval, where's the y values? Well, they're all up here. They're all positive. Okay. You know, because for the function value, the y value to change from positive to negative, say, the only way for that to happen is that it has to come through the x-axis. It has to go through a 0. That's the only way for it to get from up here to down here. Okay. So this is kind of just the theory behind how this test point method works. We're going to draw a number line, and that number line is going to represent the x-axis of the plot of the function. We're going to label the points where the zeros occur, and we're going to find those. You can find them by factoring, or you can use the quadratic formula. Then we're going to pick some x value any x value in each interval, it doesn't matter what number you pick, calculate the corresponding function value, the y value, by just putting x into the function, determine if y is positive or negative, and then all the y values in that interval will be the same sign. They will all either be positive or negative. So again, same quadratic we looked at on the previous page, which is plotted right here, and we had already factored it. So from this we know that the zeros are -2 and 4. Okay. So my interval, this interval is -infinity to -2. This interval is -2 to 4. This interval is 4 to infinity. Exactly like we just showed those three intervals up here on the graph. Okay, so picking a test point. Now you don't pick the zeros. You want to pick a point within each interval. Okay, and within each interval just pick the easiest possible value. Obviously between -2 and 4, I'm going to pick x equals 0 because that's easy. Okay, so that's my test point for that interval. This interval, 4 to infinity, I don't really care. I'm just going to pick x equals 5. And this interval, -infinity to -2, again, I don't really care. I'm just going to pick x equals -3. Okay. Now, for each of those values of x, we want to plug them in to the function and calculate y. All right? So in other words, for x equals -3, I want to calculate what is f of -3. Okay, I'm going to go off to the side. I do not have room to do this right here. So f of -3 would be -3 quantity squared minus 2 times -3 minus 8. So this is +9 minus a -6. So that turns into a +6 minus 8. So I've got 15 minus 8, so that's 7. So f of -3 is 7. And you know, if we kind of look at the graph, so this is what, 1, 2, 3, we can see that point right there, 3, 7, okay? The value of 7 is not really important. All I really care is that the function is positive there. That is all I care about. For our middle interval, x equals 0, then again, always pick that unless it's a 0 because it's easy. 0 squared minus 0 minus 8 is just -8. So in other words, f of 0 equals -8. And obviously the sign of the function is negative. In our third interval, x equals 5. Okay, I won't write this out, but do exactly the same thing. 5 squared is 25. Minus 2 times 5 is 10. So 25 minus 10 is 15. Minus 8 is 7. And so the sign of f of x is positive. So again, this is what we're trying to find. This is the important stuff. For each of these intervals, what is the sign of the function? So now, say if we wanted to use this information to write this solution, where is the function less than or equal to 0? Okay, well, it's less than 0 here, and it's equal to 0 here and here. Okay, so you have to be very careful about those endpoints, because I want to include the endpoints -2 and 4 in my solution. All right, so on to the next objective for this section was solving polynomial inequalities, which, by the way, is exactly the same thing we just did. A quadratic is a polynomial. It's a degree 2 polynomial. Now, the only thing different here is that we're going to look at cubic polynomials. So that's polynomials of degree 3. But looking at the problems in this section, specifically I'm looking at page 851 in the book, they are all already factored for you. Okay, so don't get scared off by the cubics. They've got them all factored. Okay. All right, so let's look at this one. So the polynomial is 2x times x plus 1 times x minus 1. And we want to know, where is that function value greater than 0? Okay. So find which x values give a function value y that is greater than 0. So again, it's much easier to solve it if we're looking at a graph of it. So here's a graph of it, and this is a very typical behavior for a cubic polynomial. From the graph, we can see that the zeros are here. Sorry, this is kind of small on the screen, but I know you have your copies. So at -1, 0, and +1. Okay, so the zeros are at x equals -1, 0, and 1. And again, we want to find, where is y greater than 0? Well, it's positive here above the axis, and it's positive here. Okay. But the solution, remember, we have to quote in terms of the x values. Which x values give us those y values that are greater than 0? Well, the x's from here to here will give us that positive y output. Oops. And the x's from here on up will give us a positive y output. Okay. So the solution, the x values that give us a y greater than 0, is going to be in this interval here. Okay, so -1 to 0. And notice I'm using parens. I'm not including the endpoints because this is just a greater than. It's not a greater than or equal to. And then also from here on up. So I have to do a union, and that is from x equals 1 on up to infinity. Okay. All right, so now let's pretend we don't have the graph to help us. We're going to kind of do this again analytically using this test point method that we just did on the previous page. Okay. So we want to find the zeros using the zero product principle. Let's just come on down here. So if 2x times x plus 1 times x minus 1 equals 0, then either 2x equals 0, which means x equals 0, or x plus 1 equals 0, which means that x equals -1, or x minus 1 equals 0, which means that x equals 1. Okay? So that's just finding the zeros analytically. Draw a number line, again, representing the x-axis, label the zeros. All right, so we've got 3 of them, so obviously let's just put 0 right in the middle, and then let's put -1 here, and +1 up here. Okay. So we're essentially just dividing the number line up into intervals. Notice this time we have 1, 2, 3, 4 intervals. Or we could have drawn them up here. Here's 1 interval, 2 intervals, 3 intervals, 4 intervals. Okay? All right, so let's just list the intervals. The first one is everything from down here up to -1. So in other words, negative infinity to -1. All right, then we just have this little interval from -1 to 0. Then we have this little interval from 0 to 1. Then we have this interval from 1 on up to infinity. Okay. All right, next step, I'm on the third bullet here. Pick some value, any x value, in each interval. And remember, we can't pick these values. These are the zeros. We have to pick something within the interval. All right, so in this interval, I guess the obvious choice would just be -2. Now this is going to be a little bit of a hassle because we got to pick something in between -1 and 0. So let's just go right in the middle and pick -1/2. Same thing here, let's just pick +1/2. And then here, let's just pick x equals 2. Okay. Find f of x. Okay, keeping in mind that all we really need to find is the sign of f of x. So, okay, let's go with this. For x equals -2, okay, and we're going to plug it in to this. This is the function we're talking about. All right? So let me come off to the side. I want to find f of -2. So let's just substitute in -2. All right, so it's 2 times -2 times, okay, it's x plus 1, so -2 plus 1, and -2 minus 1. So 2 times -2, that's -4 times, okay, -2 plus 1 is -1, okay, times -2 minus 1 is -3. All right, so negative, 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 it's going to be -12. All right, so f of x is -12, and the sign of f of x is negative. And if you come, back up to the graph here, this is the interval we're talking about right now, and sure enough, the y values, the output, are negative. Okay? All right, now -1/2. Let me come off to the side here. So I've got f of x. So in this case, f of -1/2. Now at this point, we're like, this could be a giant hassle because I don't feel like calculating this for this fraction. Well, let's try this. So it's going to be 2 times -1/2. That's the 2x. then times the quantity x plus 1, so negative 1/2 plus 1, and then times the quantity negative 1/2 minus 1. Now here's the thing. I don't really care what f of negative 1/2 is. All I care about is it positive or negative? So in fact, we don't really need to evaluate this. We just need to evaluate what sign it's going to be. So let's just think about that. 2 times negative 1/2, that is definitely negative. Negative 1/2 plus 1, well, that's the same as 1 minus 1/2, which is 1/2. So that piece is positive. Negative 1/2 minus 1, so we're already negative, then we're subtracting more. Well, that is definitely negative. So in other words, I'm going to have a negative number times a positive number times a negative number. Negative times negative turns into positive. And that is all I need to know. I don't even care what value this is. So let's just call it good there. Let's not worry about the value of f of negative 1/2. We know it's going to be positive, and that's all we care about. And again, come back to the graph. We're talking about between negative 1 and 0. And sure enough, the function value is positive there. Okay? So let's try that same method for f of positive 1/2. F of 1/2, all right, so it's 2 times x, so that's 2 times 1/2. Sorry, that's a times 1/2. And then times x plus 1, so 1/2 plus 1. And then times x minus 1, so that's 1/2 minus 1. And then let's just go through and look at the signs. Well, 2 times 1/2 is obviously positive. 1/2 plus 1 is obviously positive. 1/2 minus 1 is negative. So positive, positive, negative, all right, that is going to be negative. Okay? Don't care about the value. All I need to know is that it's negative. And again, if you come look at the graph, right now we're in this interval, and sure enough, you can see that the y values are negative. All right, our last interval is 1 to infinity. Our test point is 2. All right, so if we look at f of 2, all right, so it's 2x, so that's 2 times 2. And then times x plus 1, so 2 plus 1. And then times x minus 1, 2 minus 1. All right, so this one, 2 times 2, that's positive. 2 plus 1, that's 3, is positive. 2 minus 1, that's 1, that's positive. Everything is positive, okay? So that is going to give us a positive result. All right. So you see how everything we've done down here exactly confirms what we saw in the graph up here. So say we want to write this solution again to where is this greater than 0. So greater than 0, positive, here and here. And again, there's no greater than or equal to. We're not including the endpoints here. So I'm just going to take, the insides of these intervals. So again, we already wrote it up there, but let's write it again. So from -1 to 0, and because there's 2 separate pieces of the interval, I have to use the union symbol with 1, comma, infinity. Okay. All right, I tell you what, that's all I'm going to do for now. I do, you know, hopefully I'll see you guys Wednesday night, and if you have any questions on this stuff, make a note of it and bring your questions on Wednesday, because then I'm going to go on from here, which is solving rational inequalities.